Good morning. So last time, during last two lectures, we have tried to understand how powder metallurgy process stages are used. First stage is to prepare powder. So we have seen various methods of manufacturing powder. Second is mixing or adding some additives. It may be either the liquid binders, solid binders, or alloying elements, and thereafter it is mixed properly. The third stage was compacting. We have discussed compacting during our last lecture. I'll quickly revise the methods of compacting. So compaction is a step in which the blended, that is mixed powder, are pressed into shapes, that is, it is given a shape of the required product, and the purpose of compaction is to obtain required shape, density, and particle to particle contact to make the part sufficiently strong for further processing. The powder is fed into the die by a feed shoe, and the punch is pressed into the die. The pressure used are actuated either hydraulically or mechanically. એટલે શું કે જે બી પ્રેશર આપણે એપ્લાય કરીએ છીએ પંચને ડાયની અંદર પાવડરને કોમ્પેક્ટ કરવા માટે એ પ્રેશર ફોર્સ એપ્લિકેશન આઈધર હાઇડ્રોલિક ઇક્વિપમેન્ટથી આપીએ છીએ એટલે હાઇડ્રોલિક સિલિન્ડરથી or some mechanical means of application of force. The process is generally carried out at room temperature and sometimes at elevated, that is higher temperatures. The pressed powder and the shape gained product is called as green compact. It has low strength, but it has the same size, shape, and density as the product is in the final stage. The green parts are very fragile, that is, they can break easily, they can crumble or become damaged very easily. This situation is exacerbated by poor pressing practices. That means આવું પાર્ટ ખરાબ થાય, બહુ ઓછી સ્ટ્રેન્થનો બને અને વચ્ચે વચ્ચે તૂટી જાય, એવું ક્યારે થાય? જો તમારું પ્રેસિંગ પ્રોસેસ બરાબર ના થઈ હોય તો. To obtain high green strength, the powder must be fed properly into the die and proper pressure must be developed throughout the part. That is, uniform pressure is required. So compaction is done, and the diagram here, stage 1, 2, 3, 4, shows how the powder is put into the die. So this is your powder feedstock. Powder is placed over here. Blue color is indicating the powder. So this blue color element is powder. The central part is the core. This top is called as punch. This is the lower part of punch, and this is the die. Core કેમ use કરી છે? કેમ કે જે પ્રોડક્ટ છે એમાં સેન્ટ્રલ હોલ આપણે જોઈએ છે. So once we put in the required quantity of powder, then the upper punch comes into action and lower punch also gets into action. By application of force, they compress the powder particles that are present inside, and this is ejected by the lower punch coming out and upper punch being removed. So what we get is a compacted shape. So this is our green compact. Okay. Another example of die tool wherein you are making or manufacturing a spur gear type of shape. So your punch, upper and lower punch, will have the shape of gear, and the die will also have the shape of gear, so that whenever you are pressing the compact blended powder, you will get the required shape. Also, the central hole in the gear is prepared by inserting the core in. So, these are different metals or metallic powders for which if the product is prepared from aluminum, brass, bronze, iron and so on, the pressure ranges are given over here. These are the generalized pressure ranges. So aluminum you get 70 to 275 MPa of pressure. For iron the pressure is around 350 to 800 MPa. So you must remember these pressures. This may be asked somewhere in your multiple choice question. Different methods of compaction, that is isostatic pressing. Isostatic means iso means constant, static fixed, non-moving. So green compact may be subjected to hydrostatic pressure in order to achieve more uniform compaction and hence density. Compaction જે કરીએ એટલે કે આપણે જેટલું પ્રેશર એના પર યુનિફોર્મ એક સરખું અને વધારે લગાવીએ એટલે શું થાય બધા જ પાવડરના પાર્ટિકલ્સ એકબીજાની સાથે સંકોચાઈને ભેગા થાય. This process is also called as cold isostatic process or cold isostatic pressing, and the short form used is CI. The metal powder is placed in a flexible rubber mold, typically made of neoprene rubber, urethane polyvinyl chloride, or another elastomer. The assembly is then pressurized hydrostatically in a chamber, usually using water. Most common pressure is 400 MPa, although the pressures up to 1000 MPa may be used. This is used for making automotive cylinder liners. Have you seen cylinder liners? This is the setup for hydrostatic CIP process. That is blue color is our powder, metal mantle that is working as a core, and the mold seal, that means once we insert the powder in sufficient quantity we have to seal this setup. The fluid around the core and the mold is made from rubber, so that whatever pressure is there in the water, that pressure will be applied on this rubber and ultimately it will be applied on this blue color powder part. Since the internal part is metal mantle, it don't change its shape, so we get a compact in this. Next process is hot isostatic pressing. The only difference is cold to hot. Again, here the container is therefore made from steel instead of rubber, and pressing medium is high temperature inert gas. What is the difference between cold isostatic pressure pressing and hot isostatic pressing? There the mold is made from rubber or flexible material. Here so using hot isostatic process there are some advantages, and these advantages are complex shapes with low wall thickness can be produced. Mechanical properties are nearly equal to those of wrought products, that is castings. Dimensional tolerance are good. High production rates can be achieved. One of the limitations is that high cost and limited availability of fine metallic powders. Other processes that are used for compaction are forging, that is powder forging, rolling, called as powder rolling, extrusion, pressureless compaction, and spray deposition. Just look at the diagrams, figures that I shown, that is photograph. This is the hot rolls, and from here the powder is compacted. So it is a rolling process, powder rolling process. There is a base metal, and in base metal you are rolling up the powders. In another case, spray deposition. Here you have base metal on which you need to develop a very thin deposited cover coating, and this is done by hot or powder spraying method. Okay, so these are the discussions related to compaction. Now we'll continue with sintering.
Compacting, cold isocompact isopressing, hot isopressing, isostatic pressing. So these were the compact. After compacting, what is obtained is called as green compact, or the part is called as green part, and it has very low strength. It is just bounding, or the particles are just binded with each other, but they are not able to get sufficient strength for the functioning purpose. Okay, so therefore the next stage in powder metallurgy component manufacturing is called as sintering process. So you are seeing the picture of a particle bonding on your screen, and the particle bonding is showing you some changes. First figure shows four balls representing the particles of the powder metallurgy compacted component. Second is showing the increase in bonding area. If you see over here, you have a very small bonding area, that is contact area is less. So second is showing that this bonding area is slowly increasing, and this central porous part, that is non-contact part, is decreasing. And the third figure shows that almost everything has bonded and only a small point of porosity is remaining. So this is the process, or this is the phenomena that takes place when we put a part in the sintering process after making a green compact or green component. Okay, so just look at this. What are these? Powder particles after pressing, powder particles during beginning of sintering, that is coalescence is occurring. That means different areas, different points which were in contact have started melting and getting associated with each other. And the third is change in pore size. So this is your pore size which gets reduced after the complete as the sintering process proceeds. Okay, so this is what happens when we do sintering, and it is expected to be done very nicely so that we get a very good strength of the material particle in the bonding condition, in the metallic bonding condition, and material can be used for performing the required function with the required physical and mechanical properties. Okay, now what is sintering? Wordly, if we say, sintering refers to the heating of green compact in an oven. The heat is supposed to join various grains, that is metal powder, into single mass, thus developing the necessary strength. The strength obtained in the process depends on the temperature and the time the powder compact is supposed to be in the oven. Supposed means different metallic powder are required to be kept in oven for different times. So all the green compact are not having same time of sintering. So sintering time is different for different material and different properties that we desire to built in the material or component that is manufactured. So what are the different components of the sintering furnace? So the sintering furnace is generally a conveyor belt mounted. There is a furnace and there is a conveyor belt which is constantly moving with very slow speed. And what will be the speed of this belt? Almost 1 meter per hour. 1 meter per hour or still less than that. Because what we have is a compacted part. Last time we have seen a video that was showing how the compacted part is sent to the furnace. So it is a inline process, continuous process. So your job is falling or placed on this conveyor. It goes into the furnace. So your furnace starts from this point and it is so large, almost 5 to 10 meters long. Okay, so this part which is called as preheat part, here the temperature is around 250 degrees, so that some moisture, gases, the lubricants, oils, other things that are present in the green mold or green compact part gets evaporated and are removed in this section. So this part, the length of this part depends upon the speed of the conveyor belt, and secondly it also depends upon the time for which preheating is required. For example, if we say that a preheating of 40 minutes is required, then the speed of belt is 1 meter per hour. So then what do you say? What would be the length of this preheat? It would be around 1 or 1.5 meter long. 1 or 1.5 meters long, because if part comes into over here, it has a temperature which is room temperature. It requires some time to get up to 250 degrees centigrade, and thereafter complete part is to be soaked into 250 degrees centigrade for 40 minutes, say. Okay, we have seen this process in our heat treatment chapter, where initial temperature rise to final temperature, then soaking time, and then after we cool it or quench it. So here we don't have to cool it or quench it. Once it reaches a temperature of 250 degrees centigrade, it should remain in this furnace only. So since furnace is stationary, part is moving, so part should be moved at a velocity so that it remains 40 minutes or 45 minutes in this 250 degrees centigrade when it after it achieves a temperature of 250 degrees centigrade. Similarly, there is a sintered part or sinter oven furnace in part where the temperature is around 1100 degrees centigrade, and once the part enters this area, it should remain here for around 2 hours, 3 hours or so, depending upon the bonding strength required and the metal and alloys that are used for making powder metallurgy component. Okay, so this is very important. Speed, and or you may call it, the belt will be stopped once the part reaches this point. The belt does not move. It may be, but it is a continuous process, so belt will keep on moving slowly and slowly. Next stage is, generally this time for sintering goes up to a day or half day or so, and so this material, when it reaches into the center part of the furnace, it is generally stationary. Once sintering time cycle is completed, the part is then moved to another insulated part where it is cooled under controlled condition. Cooled under controlled condition so that products of oxidation and corrosion does not affect the component that is manufactured or that has been sintered out over here. So this is the process cycle in sintering. and you have to draw a neat diagram of this process cycle in your journal. Okay, indicating different zones and different temperatures also. Okay, so we are talking about different temperatures for different materials. Brass generally we get 850 degrees centigrade and typical time is 25 minutes. Bronze we get to 820, time is again 15 to 25 minutes. Iron you see 1100 30 minutes. Stainless steel 1200 45 minutes. Tungsten 2300 degrees centigrade and 480, that is 4 hours. Okay, so in this way we get this time and temperature cycle, and these cycles must be performed properly, operated properly to get the good quality of job from the powder metallurgy green compact. The furnace has three zones. You can take notes of this. Furnace has three zones: preheating, sintering, and cooling zone. For steel, sintering temperature is around 1100 to 1200 degrees centigrade, and for copper it is around 800 to 850 degrees centigrade. The strength achieved by the sintering process or by the component after sintering depends on the sintering temperature. The trip through the furnace for a single part takes around 2 to 3 hours. That means starting from preheat, sintering and cooling, it takes around 2 to 3 hours or more as the part product component would require. So now sintering process. There are some secondary process that are used along with sintering or after sintering. So one of them is repressing. Repressing is performed on powder metallurgy components to increase the density and improve the mechanical properties. What is done? Like in our hot working process, when the part gets cooled off, we again put it into the heat bath or furnace so that it gets a temperature of red hot, and again we can work. Same thing is over here. Once sintered component is available, it is before cooling it is pressed in the press. During repressing, the density of part is generally increased, especially if the as sintered density is low. As sintered means whatever you have obtained from sintered component, જે બી આપણને મળ્યું હોય એ sintered component ની density આપણે વધારવી હોય તો before cooling સિન્ટરિંગ પ્રોસેસ પતે ત્યારે ટેમ્પરેચર કેટલું છે અરાઉન્ડ 800 થી 1100 ડિપેન્ડિંગ ઓન ધ મટીરિયલ. તો એને સીધું લઈને ફરીથી પ્રેસ કરવામાં આવે. તો એને પ્રેસ કરવાથી શું થાય, એના પાર્ટિકલ્સ વધારે કોમ્પેક્ટ થઈ જાય અને કોમ્પેક્ટ થાય એનો મતલબ કે ડેન્સિટી વધી ગઈ. સો this is done for increasing density, and by that we improve the mechanical properties. In certain cases where strength and other mechanical properties are required to be at maximum, repressing is used principally to achieve such densification. Further improvement is achieved by re-sintering. એટલે પ્રેસ કરીને ફરી પાછું એને સિન્ટર કરવાનું. એટલે ફાઇનલ જે બેસ્ટ ક્વોલિટી હોય એ આપણને મળી જાય છે. Another secondary process which is done after sintering or immediately with the sintering, sizing, is performed to modify the surface shape and provide stricter dimensional control. That means જે component બન્યો છે એ componentની shape size આપણે accurate બનાવવા હોય તો એના માટે આ છે. Sizing is done in the die that was used for compacting the powder In those cases where the dimensional change on sintering is controlled at or very near to zero, but commonly separate sizing tools are used. Okay, so there are 2 points in this statement, that sizing may be done in the die which was used for making the green compact, or second is they may have special dies which are built just to confirm and to make the required shape and size of the product after sintering. Generally, another die will be used because whenever it is green compact, the shape size will be quite small, slightly larger. As the heating is done, sintering is done, there are chances that the green compact may shrink in, so that small amount of dimensional tolerance on negative side will be available. Heat treatment is also used. So powder metallurgy component can be heat treated to improve strength and hardness, can be steam treated to make the surface hard and more wear resistant, as well as contributing to improved corrosion resistance and sealing of property porosities. Okay, so what are the different points in this statement? Heat treatment is done to improve strength and hardness. Then treatment. Steam treatment is done for making surface hard. That is, surface hardness is improved by steam treatment. And wear resistance is improved. Thus, we also use heat treatment to improve the corrosion resistance and also to block or seal the porosity. એટલે કે જે પોરોસિટી સરફેસ પર દેખાતી હોય એને ભરી દેવા માટે હીટ ટ્રીટમેન્ટ યુઝ કરીએ છીએ. હીટ ટ્રીટમેન્ટ અને સ્ટીમ ટ્રીટમેન્ટ બે યુઝ કરીએ છીએ. During the quenching process, because of porosity inherent in sintered parts, they should not be immersed into corrosive liquids such as salt bath water or brine, and only oil cooling is preferred. સો જો હીટ ટ્રીટમેન્ટ પાવડર મેટલર્જી પાર્ટના કરીએ છીએ તો એમાં આપણે ક્વેન્ચિંગ કરવાનું જો આવે, આગળના હીટ ટ્રીટમેન્ટમાં આપણને ખબર છે ક્વેન્ચિંગ એટલે શું. તો ક્વેન્ચિંગ કરવાનું આવે તો એને કરોઝનનો ઇફેક્ટ ના થાય એના અંદર કરોઝન અવોઇડ કરવા માટે આપણે એને સોલ્ટ બાથ અથવા તો વોટર ઓર બ્રાઇનમાં કુલિંગ માટે નથી નાખતા, એને ફક્ત ઓઇલ કુલિંગ જ કરીએ છીએ. હીટિંગ શુડ ઓલ્સો બી ડન ઇન ગેસ એટમોસ્ફિયર. એટલે જ્યારે એને ગરમ કરીએ છીએ ત્યારે કંટ્રોલ્ડ ગેસ, ઇનર્ટ ગેસ એટમોસ્ફિયર રાખવું જોઈએ, ઓર કાર્બન મોનોક્સાઇડ ગેસ એન્વાયરમેન્ટ રાખવું જોઈએ, જેથી ઓક્સિજન એ પ્રોડક્ટના પાર્ટિકલ સાથે રિએક્ટ થઈને ઓક્સિડેશન ના કરી શકે. Okay, so now we are moving towards the completion of the part, that is powder metallurgy. We have seen the powder metallurgy topic into three different stages. One is powder, second is blending, third is compacting, and fourth is sintering. So we have seen this chapter into four different group parts, stages, and finally the powder metallurgy component is out after sintering process. So what are the advantages of this process? The powder metallurgy parts can be produced to the neat net shape requiring very little finishing operations. Neat means exactly, net means required dimensions, very little with very little surface finishing or finishing operations. એટલે કે કોઈ finishing operation આના પછી generally જરૂર નથી પડતા, અને જરૂર પડે તો બહુ ઓછા જરૂર પડે છે. Okay, it is possible to achieve a surface finish between 0.8 to 1.2 micron from a die with a surface finish of the order of 0.5 to 0.8 micron. એટલે ડાયની જે સરફેસ ફિનિશ સારી હોય તો આપણને 0.8 ટુ 1.2 માઇક્રોનની સરફેસ ફિનિશ પ્રોડક્ટની અંદર મળી શકે છે. Powder metallurgy process will not cause any waste products during the processing and as such is very economical. ઓકે, એડવાન્ટેજ શું છે કે કોઈ વેસ્ટેજ નહીં બને. વેસ્ટેજ બહુ ઓછું હોય છે આની અંદર, એટલા માટે એને ઇકોનોમિકલ કહીએ છીએ ફ્રોમ પોઈન્ટ ઓફ વ્યૂ ઓફ વેસ્ટેજ. Good complexity of shape, that is reasonably complex shapes, can be produced by powder metallurgy which cannot be economically machined or casted. ઓકે, એટલે મશીનિંગ કાસ્ટિંગથી ના બની શકે અથવા મશીનિંગ જેનું પોસિબલ નથી એવા ટિપિકલ કેસીસ કે જેની અંદર કોમ્પ્લેક્સિટી વધારે છે એવા કમ્પોનન્ટ સારી રીતે પાવડર મેટલર્જીથી બની જાય છે. It is possible to produce parts with a combination of materials that is not possible by other processes. એટલે કે શું કે આની અંદર એવી અલગ અલગ ટાઈપના મટીરિયલના પાવડર મિક્સ કરીને પ્રોડક્ટ બનાવી શકાય છે જે નોર્મલી બીજાની અંદર બીજા કોઈ પ્રોસેસમાં આપણે મિક્સ કરીને નથી બનાવી શકતા. ફોર એક્ઝામ્પલ, metals and ceramics can be intimately mixed. Certain metals that can be manufactured by other processes can be done by powder metallurgy. Cannot be manufactured by any other processes, can be done by powder metallurgy, and example is tungsten and tungsten carbide. Provides controlled porosity for self lubrication by infiltration of lubricating oils. એટલે કે અંદર પોરોસિટી છે જ થોડા ઘણા પ્રમાણમાં, તો એ પોરોસિટીથી શું થાય, જ્યારે આપણે લુબ્રિકેશન ઓઇલિંગ કરવાનું આવતું હોય તો એ પોરોસિટીથી ઓઇલ ઓટોમેટિકલી લુબ્રિકન્ટ અંદર જઈ શકે છે. So limitations: the tool cost is generally high and therefore can only be justified for mass production. Raw material cost is high. Because of the presence of residual porosity, the mechanical properties are inferior, એટલે કે થોડીક ઓછી compared to cast, machined and forged products. Okay, so this is about the process of powder metallurgy. We have covered the complete chapter in 4 parts. Finally, we have seen some advantages and limitations in initial stage, or in the first 2 slides or 4 slides. I have also explained the applications of these products that are manufactured by powder metallurgy. So, taking this topic to the end, we will give you one assignment wherein you will have to write the question answers and also draw the required diagrams in a descriptive mode. You can use the papers at your home. You may write it in the notebook also. Okay, and whenever, so that you get prepared with your question answer and exam point of view, that this reading can be used for exam point of view also. So we'll give you a test maybe on next Thursday for 1 hour based on powder metallurgy chapter. All of you should write and submit the test within time. Okay, 1 hour ટાઈમ રહેશે, 1 કલાક. એની અંદર આપણે અમુક તમને સબમિશન માટેની અસાઇનમેન્ટ હશે ક્વિઝવાળી, અને અમુક ડિસ્ક્રિપ્ટિવ ક્વેશ્ચન હશે. ડિસ્ક્રિપ્ટિવ ક્વેશ્ચનના આન્સર તમારે નોટબુકમાં કે પેપર પર લખીને એના ફોટા પાડીને ફટાફટ માઇક્રોસોફ્ટ ટીમ્સમાં ચડાવવાના રહેશે. We will download and note it and put it as your record for class test. It is not the internal test but for class test, so that you get prepared and we too get to know whether you are studying properly and you are getting the things in a proper mode or not. Okay, so we stop here for today.